Hello everyone, in this video I'd like to introduce Monkey See Monkey Do Linux, which is a didactic Linux distribution that I've built absolutely from scratch, and the process of building this distro was covered within the tutorial series here on YouTube as well. So let's boot. And we are in. So first I just want to connect to the network. And then I'll need to run a couple of scripts to install the desktop environment. So last video, I've been doing things manually. Now the automated scripts are provided and they are now the part of the ISO. So first I need to do install base, rename the install script to install base. So essentially what it does is it installs the DiPy, which is the package manager that would be downloading packages from Tinical Linux repository. And it already downloads the CA certificate, CURL, and Git, and the VICI text editor, the one that I've written on my own, a text editor I'm using to record my programming tutorials. Okay, and the next script is called install xfbdev, which would install the entire desktop environment. So let's run the install xfbdev. It takes quite a bit of time, and by the time it will be installing, I would like to say a few words in this regard. So usually xorg is used as the X server. That's probably the most well-known one. But Technical Linux community has created a thing called xfbdev. The idea behind this tiny X server is that it writes directly to dev/fb0 to the frame buffer device. It has both like pros and cons. Obviously, the next step for this project would be to provide the Xorg version. But since Xorg is not going to be working nicely under the QEMU, because it would be really hard to properly configure the Visio drivers, then I'll probably run this on the real hardware. Now I'm running on the emulator. The reason behind this is not because I cannot record video under the Monkey See Monkey Do Linux. I actually can, but it's very slow again due to the xfbdev itself, because it's really slow. Okay, by the time it has almost completed the installation, so it asks me to select the mouse type. I press 1 here. So if you're running this under the QEMU like I do, press 1, this should work. Yeah, by the way, you can reproduce the steps being presented in this video if you just go to github.com and my repository and the Monkey See Monkey Do Linux. I'll give you a link in the description down below the video. You can just download the ISO, and there is the specific QEMU command that sets up video and gives 2 gigs of RAM to the emulator to make it possible to run things. And you can do exactly the same steps I'm doing now. So now everything has been installed, and I just say start X, and this should bring me to the desktop environment. And here we are. So let's start from the very beginning. So we have a terminal emulator, probably the most essential thing to have a look at. So you see, like, the resolution is not native here. The native resolution is 1366 by 768, and when I run this on the real hardware, it works like a charm. It's not that prolonged like it's in here, so it's not an issue. But under the QEMU, unfortunately, the resolution is not really that perfect. But for the purposes of demonstration how things are actually working, I think that's fairly enough. So what do we have here? We have the following thing. So if I just list the hidden files here, you see all these JWMRC files are the configuration files for the JAWS window manager that I've configured to look exactly like it does. But probably let's start with set background thing, because yeah, setting background makes things really really cool looking. So I say VICI because my VICI text editor is now already been installed here, and I run the set background. So just using the hset root application, which has been installed on the way, and just then provides the path to the wallpaper.jpg. That's how we can obtain this nicely looking desktop image being like desktop wallpaper being applied. Then let's have a look at Xsession. That file is generated by the xsetup which is get and install from Technical Linux repositories. I do some adjustments there. I can probably show you that. So it sets up the xfbdev as the X server, provides the mouse, doesn't listen to TCP because we don't simply need this. And then it runs the desktop. Desktop is just the environmental variable. Essentially, this is the JWM, Joe's Window Manager. And then we do set the background. Then we set in the font to Terminus, like this font, updating things. And also don't forget to make the dev PTS temporary file system, because without this device, the graphical terminal emulator is not going to work. So that's absolutely essential thing. So let's quickly walk through the scripts that we have been running. So starting with, let's start with has been Ethernet. Well, this is quite simple. So we just loop over all of the devices available under the sys class net, activating the device by setting it up. And then for all the devices but the loopback, we are calling the UDHCPC to dynamically obtain the IP address, running things in the background, specifying the device itself, and calling the @network shell as the callback script. What @network shell does, it's simply, I can probably show you, it's simply network sets up the IP address and uses the IP mask and interface are the environmental variables that are produced by the UDHCPC utility, which is the part of the busybox. Yeah, by the way, I probably forgot to mention that this is the busybox based distribution. So it started with just statically linked busybox and Linux kernel, and that's it. No drivers, nothing, essentially nothing there. And yeah, since then, lots of things has changed. Yeah, so then we are setting up the router. And finally, if we do manage to obtain the IP address, that it gets printed. Well, probably it has been printed. I just didn't really mention that. Okay, now let's have a look at I guess this is bin and install base. So this is the screen. Yeah, by the way, we can make the VIM window full screen like this. So first, it just downloads DiPy, which is the package manager. I will show you how DiPy works. It's quite cool. Then unzips it, then copies to the user bin folder. Then it loops over the packages under the adds package list. And depending on what package it is, it might need to do some additional adjustments. Like for instance, for CA certificates, it needs to create a directory and run the update to certificates. If you're trying to install Python, for instance, that needs some extra step as well. Python is not installed by default, but it can be installed quite simply. I can probably show you that as well. Okay, yeah, but since this package, if I do install Python by hand, in this case, I need to run these commands manually, because it will only get done automatically if I have run the install packages script, and if I do have Python 3 under the base packages. But since it's not really that important for the base packages, which only have the utilities to make it possible to format the disk to the proper partitions and make file systems there, so that I could install monkeys and monkey Linux on the real hardware. So that's the purpose of the base package installer. Yeah, finally it installs the VICI text editor. So, okay, I promised to show you how DiPy works, and I promised to, okay, I'll probably install Python. What else? Yeah, and some more scripts to show as well. Yeah, probably let's do let's have a look at some other scripts. So if I do ls-a again, so we have the X folder here. So I go to the X folder, and here we have the install xfbdev script. So let's quickly have a look at that as well. So this script installs the entire desktop environment. So we have the xfbdev, which is the TinyX server, and Joe's window manager. So first, again, the list of the packages. Yeah, just before I forgot. So just away from here. So first, I just want to show you the packages for base package available at adds packages. Yeah, not the best of a structure, so not organized well. But anyway, so util Linux to have the things like fdisk, e2fs procs to have mkfs ext4, C certificates to be able to make HTTP requests, CURL, self-explanatory, Git as well. So also CURL and Git are used within the install xfbdev, so they are essential. But if you don't want the graphical environment, if you don't want the graphical desktop, you can still use this base installation. If you want to install some more, you can use DiPy Package Manager from the command line, not obviously from the graphical interface. Obviously, that's the case. Okay, so what now? Now probably, yeah, we can, let's see again the install shell. So what's happening here? Just a very quick overview. So here is another package list. If I just cat packages from here. So these are the dependencies for the graphics and stuff. The most notable ones are xfbdev, FLTK 1.3, JWM, the essential things. A whole lot of libx, etc. for just to make sure all the dependencies are resolved properly. ATerm is the terminal emulator I'm currently working under. Then what? It also xprocs contains some useful things like the, for instance, like the visual text editor, which is also cool. So here is the editor where you can just, it's essentially, this is the notepad clone, but it's not really that simple as Notepad. So it has syntax highlighting, which is quite satisfying. So for instance, if I try to have a look at the source code of my text editor VICI, then here we go. So it just highlights the syntax quite nicely, which is really fantastic. Cool editor, really cool editor. Probably not as cool as the one I've written. I probably shouldn't say that, but better. It would be better if the users would say that, not me. But anyway, I just like my editor more. It's the only way. That's the only thing I meant actually here. Okay. So let's go back again here, and what we have. So we loop over the packages that I've just shown. Then we make sure that the owner belongs to Moki group, not to the staff group, which is specific to Linux. So to make sure things are working, like who owns the Xsession file, for instance, we need to make sure that the staff is replaced with MSMD. Then I'm symlinking all the libraries that has been downloaded as dependencies and stored onto the user local lib, and all the .so files are symlinked to just the lib. Okay, then I create the infrastructure specific to Linux to make sure that the packages are working properly. So it needs the directory as scale, as inid to contain the tc functions to color screen and do some things like that. I could have avoided that, but it was just easier and simpler to keep it there. Then sysconfig contains three essential files: the X server file, the desktop, and the TC user. And these are used these are used by the X install, by the X setup shell, which installs the graphical environment here, and eventually produces the Xsession file based on the template, but still it produces a custom one because it might be driven by xfbdev, by xorg. So there might be different options for the x86, not the x86 64-bit like this one, but for the x86 systems, it might also be xVISA. tiny core X server thing. Okay, then we git loading core scripts from Tiny Linux to actually provide the TC functions, which is just the dependency for the installation of the graphical user interface. Select is the utility to select the mouse that you've seen, that green screen to select the type of mouse. Uh, Copying the template of Xsession to the skeleton Xsession, copying background to the home folder, creating the images, copying wallpaper to the images, copying all the Joe's Window Manager RC files, all the configuration files for the Window Manager to home monkey see monkey do, and providing the X defaults, which does the color scheme that you can now see under the atom. So that's not the default color scheme. That's the one I've created on my own. So yeah, I think it looks quite cool. Then setting up X environment. So well, starting with just running the X setup shell, which produces the Xsession file, and also I want to append sudo to the Xsession so that xfbdev would be running as sudo. Otherwise, it's not going to work. I don't know why Tiny Linux doesn't do this by default. No ideas, but this is essential for things to work. And another very important thing, we want to create the dev PTS and populate it with dev PTS temporary file system so that the graphical terminal is capable of booting, because otherwise it's not going to work. Finally, we want to install Firefox. I will now show you how the Firefox is working. So we just download the, currently the latest version, but in a couple of months it would not be the latest version anymore. But anyway, then we extract files, then we get rid of the downloaded archive. Then we symlink the libraries from the Firefox to the lib, and then we just go in back to the home directory. And after that, you can just run Firefox, and well, not Firefox, actually home msmd, which is the username, Firefox. But there is the shortcut, so I can just click on the Firefox here, and this would run the Firefox browser for me. This is the first time, so I just need to walk through this nasty thing here. Let me just start browsing, please. Yes, thank you. Stop browsing. So yeah, I just want to show you the so github.com, my username, and monkey see monkey do Linux. Okay. So here are the screenshots. So here is how it looks with the normal resolution. Not the resolution we have here, but with a normal resolution. It looks like this. It's just really neat. Okay. So all you need to know, like how to do with networking, for instance, about the package manager. I will now demonstrate the package manager. A few words about the graphical desktop. So those tabs are required to recreate the experience that we are now being through. So running all these commands after booting from the ISO. What else? Yeah, I can scroll by pushing down arrow as well. So if you want to install Monkey to Linux on the hard drive, I have a separate video on this. Although the system wasn't that cool as it looks now by the time of making that video, but it has nothing to do with the actual installation to the hard drive. So that might be really relevant as well if you want to run this on the real hardware, because unlike Tiny Linux, which this distribution looks like Tiny Linux in some respect, in terms of simplicity, having the busybox init as the init system, using Tiny Linux repository as the source of the packages, or they have the custom package installer, but still. The core difference is that Tiny Core Linux never leaves the init RAM fast, and the entire file system lives in the random access memory. While for Monkey See, Monkey Do Linux, it's just a normal regular Linux distribution, which makes the switch root operation and actually switches to the real hardware, to the real hard drive. And then whatever changes has been made during the session, they would get stored. Well, obviously now I cannot demonstrate you this because I'm now booting from the ISO, but if I install everything on my laptop, which I already did, I enjoy having this system, and whatever new thing I add, it gets there after reboot, obviously. So just like a normal Linux distribution. So hopefully that makes sense. Yeah, and finally, like referencing the build script if you want to create the ISO from scratch, which would most likely not work because of the whole lot of topics that has been described within this tutorial series. So yeah, you want to have this result, if you want to build this from scratch, I highly recommend to walk through these tutorials that carefully explain every single tiny little detail, like from configuring Linux kernel and up to achieving these graphical desktop thing. Okay, so we no longer need the browser, so let's just close it. Okay, so let's play a little bit with the package installer. Okay, so what's okay? Let me just clear. Let me cd to the home directory. So, for instance, I don't have Vim on this system. I don't have Nano on this system either. So let's install these two editors. So I can say DiePy and Vim. Okay, and this is how I can install Vim. And for instance, yeah, and also let's do DiePy install. Don't have to say install, just DiePy and the name of the package. Now we should have this as it has been installed. So if I say Vim, I have Vim, great. If I say Nano, I have Nano, great. So for instance, you want to, no, please, nope, Control C, nope. Say you want to make shortcuts like I did shortcuts here. So if you go and run JWM RC and tray, then here you can do the following. So for instance, here I want to say Vim, and I want to execute a term title. This would be Vim, and I don't remember what's the execute, I guess, and Vim like this. And here I want to have Nano. And again, just call an A term since this is the not the graphical editors, but the terminal-based editors. Execute Nano. And just add a couple of separators. Copy. So say put one in here. Put one in here. All right. Wait, now if I press Control Alt R, this would update the desktop, and you see like we just created a couple of shortcuts here. So if I click Vim, yeah, it tells me like this is Vim, cool, and yeah, so I can do whatever with this, and the same for Nano, and bam, we have Nano here. I could have done the same for VICI, but yeah, just never call it from. I just always call it from terminal, so I don't quite need that. You can also remove this exactly the same way. So you just can remove those entries you don't quite need. So delete. Right click, Control Alt R. Yes, to restore things. So you just delete these shortcuts that we don't quite need. Okay. What else do we have here? So we have several desktops. So for instance, if I do Control Alt and to the right here, let's open not terminal here. Let's open the editor. Okay, and let's say Control Alt down or no up. Oh no, it's not just to the left or to the right. Okay, so here, for instance, let's open the web browser. It essentially works like tabs. Yeah, I can probably do Alt 1, 2, 3. Yeah, that's cool. Yeah, let's set it as the default browser. Yeah, that's the best shortcut. So Alt 1, the first desktop. So here, for instance, I can have the terminal emulator. Then the second Alt 2, we have the text editor, for instance, and here we have the web browser. Quite cool. Okay, we can also move windows between the desktops. For instance, moving this to desktop 4. And now if I say Alt 4, now my web browser has been moved there. And obviously, I can move everything back to the very first desktop like this. And in this case, I have a whole lot of things being opened on the single desktop. And if I want to manage things, I can just click on desktop and then everything gets minimized. On this system already, I can do my freelance jobs, like, I don't know, writing web scraper for somebody and make some money. So this system already is enough for work, for basic Python programming. Yeah, probably one last thing that I wanted to show you that, and I didn't, is the following. So, okay, let's try to do remove forcingly recursively temp packages. Okay, and let's try to install Python again. Okay, one more time. So share, yeah, under the share, Python files. Yeah, I also need to extract this. So now it's just cd there and say tar minus xvf and the files with sudo. Okay, and now I want to say sudo cp use a local everything there to the root user local. Yeah, I want to make this recursively, of course. And now if I did everything properly, I should have Python 3. Yeah, just need to spell it properly. Python 3. Okay, Python 3 from the third attempt. Yeah, now we got Python, guys. Cool. We also, for instance, once say import requests, I don't have the requests library, right? But I should have pip3 here. Pip3 install requests. Okay. Yeah, something went horribly wrong with fonts, but well, anyway, Python 3, no, not Python 2, Python 3, import requests, and now we can do response equals requests.get https, let's say example.com. Okay, now we have the response. Oh, it's not there. Oh yeah, that's because of the, like this. Okay, and response text. We got HTML text there. So yeah guys, this is it from my side. Thanks for watching and I'll see you in the next video.